Welcome to the AI for Career Success video overview by Curt Robbins, where we help you get smarter than your competition. Today, we're examining NVIDIA's next major development in artificial intelligence. This overview synthesizes the analysis and reporting from industry professionals on LinkedIn following NVIDIA's significant keynote address at the Consumer Electronics Show on January 5, 2026.
So let's begin with the central problem that's really driving NVIDIA's latest innovations. Jensen Huang, the CEO, puts it quite bluntly. The amount of computation necessary for AI is skyrocketing. And he's right. The entire industry is grappling with this exponential demand for computational power. You see, training these increasingly massive models and, just as importantly, deploying them for real-time inference, well, it requires an entirely new class of hardware. This challenge right here is the foundation for everything we're about to cover.
And so, what is NVIDIA's answer to this so-called AI compute wall? Well, it's the Vera Rubin platform. It's important to understand this isn't just an iterative update over their last model. No, this represents a fundamental architectural leap forward, specifically designed to power the next generation of AI. Now, let's look at the numbers, because the performance gains here are really quite substantial. When you compare Rubin to its predecessor, Blackwell, which was already a record breaker, you see it's 3.5 times faster for training models. But the really critical figure here, the one to pay attention to, is the 5 times increase in inference speed. Why does that matter so much? Because inference is what you need for deploying AI in real-world, real-time applications. And that, as we'll see, was a major theme of the keynote.
To really appreciate the scale we're talking about, let's look at the anatomy of a single Rubin pod. You're looking at over 1,100 GPUs organized into 16 racks. This immense scale, combined with the next-generation HBM4 memory, is specifically engineered to shatter what's known as the memory wall. Think of it as a fundamental bottleneck that has limited previous systems. The upshot? This architecture can handle models with trillions of parameters, which was, until now, a significant engineering challenge.
And it's crucial to note that this isn't some theoretical, far-off technology. As the timeline shows, the platform was fully unveiled at CES this year. According to NVIDIA CEO, it is currently in full production as of January. We're expecting to see the first products from partners become available in the second half of 2026. So this is happening, and it's happening fast.
The Vera Rubin platform is much more than just the GPU, though. It's a complete ecosystem upgrade right down to the server racks. We're seeing enhancements like context memory, which is a new storage platform for faster data handling. There's zero downtime, which points to advanced maintenance capabilities to keep these systems running continuously. And of course, confidential computing, which provides rack-scale security, absolutely vital for today's AI workloads.
Okay, so we've talked about the hardware, but what are the implications of all this power? Well, they extend far beyond the data center. This computational capability is what enables a major paradigm shift in the industry, something NVIDIA is calling physical AI. This is about moving intelligence from the cloud and the data center into the real world. So, what exactly is physical AI? The key idea here is that these are AI models that understand the laws of physics. They're not just processing text and images, they can comprehend and interact with the physical world around them. And as you can imagine, this is what's needed to enable the next wave of advanced robotics and truly autonomous systems. And NVIDIA provided a prime example of physical AI in action. It's a new AI model called Alpamayo. Think of this as the AI model designed for what they're calling the thinking car. In other words, for the next generation of autonomous vehicles. This really highlights a fundamental evolution in how these systems operate. Previous systems were largely reactive. They were trained to recognize and react to learned patterns. Alpamayo models, on the other hand, are designed to actually understand complex scenarios. They use what's called chain-of-thought reasoning, which is much closer to how a human driver might perceive a situation and decide on a course of action. And this concept of physical AI isn't limited to just cars. It's now being applied directly to the field of robotics. In fact, Jensen Huang declared that the ChatGPT moment for robotics is here. That's a very strong statement, signaling that we are now entering the era of general-purpose, reasoning-based robotic systems. To really accelerate this robotics revolution, NVIDIA announced a very significant partnership with Hugging Face. The strategy here is quite clever. They're fusing their established robotics platforms like NVIDIA Isaac and GR0T with the huge community of AI builders on Hugging Face. The idea is to connect the 2 million robotics developers with the 13 million AI developers. You're essentially creating this massive, unparalleled ecosystem to fast-track the development of autonomous bots. All right, so we've covered the technology, but what's the larger takeaway here, especially for tech professionals? Well, all of this points to a very significant and very deliberate shift in the entire industry landscape, one that's being driven by Nvidia's strategic focus. You know, sometimes the most telling detail is what isn't said. For the first time in 5 years, Nvidia's keynote had no announcements about new consumer GPUs. Now, that's not an accident. It's a clear signal of a major strategic pivot. The company is clearly focusing its resources away from the consumer market and toward the immense potential of enterprise and industrial AI. So this really outlines Nvidia's future focus. You can see the clear logical progression here. Step 1. Build the foundational AI data centers. Step 2. Use that power to create autonomous systems. Step 3. Deploy those systems into physical robotics. And Step 4. Simulate and manage it all with digital twins. This is their roadmap for what they see as the next industrial revolution. And this brings us to the final, and perhaps most important question you should be considering for your own career and your own work. Is your industry ready for the rise of autonomous agents? Because the technology to enable them is clearly arriving, and it seems poised to become a foundational tool for automation across nearly every field. Thank you for joining us for this analysis. This is where we teach you AI and help you get smarter than your competition. We encourage you to subscribe to the AI for Career Success YouTube channel. And if you found this overview valuable, please like, comment, and share it to help us reach a wider audience.